Good morning students. Welcome to science class. Let's start the bridge course session. Before that, tell me what is science? Science is a way of learning about the natural world. Science is a way of learning about the natural world. Science also includes all the knowledge gained from exploring the natural world. Once again, I repeat, science is a way of learning about the natural world. Science also includes all the knowledge gained from exploring the natural world. Do you know, children, branches of science? Science has three branches: physics, chemistry, and biology. Once again, I repeat, science has three branches: physics, chemistry, and biology. Students, what is physics? Physics is the study of the physical world, that is, the world of matter and energy. Physics is everywhere. Any problem that deals with temperature, size, motion, position, shape, or color involves physics. So we can able to know the environment and the uses in physics. Then what is chemistry? Chemistry is the study of matter, its composition, structure, properties, transformation from one form to another, and the energy that accompanies its transformation. So in chemistry, we can able to know about chemicals and how they combine with other substance. Then tell me, what is biology? Bio means life. Ologos means to study or the study. So biology is the study of life, the study of living things. Biologist, the person who studies biology. Once again I repeat, biology is the study of life. Students, today we are going to learn about basics of measurement and forces and motion, electricity and atomic structure. Now, shall we see about basics of measurement? What is measurement? Measurement is finding a number that shows the size or amount of something. In daily life, we are finding weight, length, temperature, height and time. Yes, these are the measurements used to find the value of the objects. Students, now tell me, how will you know your height? Using measuring scale, measuring tape to find the height. Like we use measuring tape to measure the length of cloths. In shop, how will you ask bag of vegetables to the shopkeeper? He will use some weighing balance to find the weight of vegetables and fruits. It may be gram or kilogram. Then, how will your mom ask milk from milkman? So, milkman using some measuring jar to find the volume of milk. It may be 200 ml, 500 ml and 1000 ml. Also, diesel, kerosene are measured by different measuring jar. I hope you all have noticed in petrol bunks. Students, our body temperature measured using some thermometers. It may be mercury thermometer or digital thermometer. Moreover, in daily life, we can able to find the speed of vehicles. Yes, object move from one point to another point means we will find the distance, speed and displacement. So, quantities such as mass, weight, distance, temperature, volume are called physical quantities. Once again I repeat, quantities such as mass, weight, distance, temperature, volume are called physical quantities. Physical quantities are classified into two types. First one, fundamental quantity, second one, derived quantities. What is fundamental quantity? A set of physical quantities which cannot be expressed in terms of any other quantities are known as fundamental quantities. What is derived quantity? All other physical quantities which can be obtained by multiplying, dividing or by mathematically combining the fundamental quantities are known as derived quantities. Once again I repeat, physical quantity is classified into two types, fundamental quantity and derived quantities. See the picture. 7 units are called fundamental quantities. What are they? Length, mass, time, electric current, temperature, amount of substance and luminous intensity. So these are fundamental quantities. Unit of length is meter. Unit of mass is kilogram. Unit of time is second. Unit of electric current, ampere. Unit of temperature is Kelvin. Unit of amount of substance is mole. Unit of luminous intensity is candela. Then derived quantity derived from fundamental quantity with multiplication, addition and subtraction. See the example. Dividing base quantities such as distance and time to find the speed. Like that, multiplying length and breadth to find the area. So unit of area is meter square. Then volume is equal to length into breadth into height. Then unit of volume is cubic meter. Then speed is equal to distance divided by time. Then unit of speed is meter per second. Then electric charge is equal to electric current into time. Then unit of electric charge is coulomb. Then density is equal to mass divided by volume. Then unit of density is kilogram per meter cube. Students, now we will study about forces and motion. Students, tell me, what is a force? An agent which accelerates a body. An agent which accelerates a body. How will you accelerate the body? Either it may be push or pull. Tell me, what is push? Push is a force to move something or someone away from oneself. Push is a force to move something or someone away from oneself. Then what is pull? Pull is a force to move something or someone toward oneself. Once again I repeat, pull is a force to move something or someone toward oneself. Let's see some examples for pull and push. Pulling the zip in shirt, tying the knot in shoe, climbing the rope, taking book from shelf, opening the door and wearing socks are the examples of pull. Then rolling the ball, pressing glue from bottle, throwing the objects, kicking the ball, put away a book, writing in a book are the examples of push. Moreover, opening a door, riding a bicycle, lifting an object is the example of force. Yes, object moving and change of direction done in force. Now we will learn about types of force. As we all know, force is classified into two types, contact force and non-contact force. Once again I repeat, force is classified into two types, contact force and non-contact force. First we will study about contact force. A force that is exerted only when two objects are touching. Once again I repeat, a force that is exerted only when two objects are touching. So while pushing the cycle we exert some force. Similarly, while writing and moving the baby cot we apply some force. Then what is non-contact force? A force that can be applied without any contact between two bodies is called non-contact force. Once again I repeat, a force that can be applied without any contact between two bodies is called non-contact force. For example, a ball thrown in air. Ball reaches the surface due to gravitational force. Like that, two charged conductors' attraction takes place. Between two charged conductors, attraction takes place. So, electric force is a non-contact force. Students, now tell me, what is motion? Motion is the transfer or movement of an object from one place to another. Once again I repeat, motion is the transfer or movement of an object from one place to another. It may be any object moving one place to another place. Now we will see types of motion. First one, linear motion. Yes, in this motion, object moving in a straight line manner. Once again I repeat, in linear motion, object moving in a straight line manner. Second one, curvilinear motion. In this motion, object moving ahead but changing the direction. In this motion, object moving ahead but changing the direction. You see the example. At the time of throwing ball moving and changed its direction by force. Third type is circular motion. In this motion, object moving in a circular path. In this motion, object moving in a circular path. See the example, spinning of ball is circular motion. Spinning of ball in circular motion. Fourth one, rotatory motion. In this motion, object movement takes place on its own axis. In this motion, object movement takes place on its own axis. For example, rotating the wheel moved in its own axis. Fifth one, oscillatory motion. In this motion, object coming back to the same position after a fixed time interval. In this motion, object coming back to the same position after a fixed time interval. See, simple pendulum. The iron ball oscillates and come back to the same position after a fixed time interval. Then sixth one, zigzag motion, otherwise called irregular motion. Here object moving in irregular path, that is object moving in zigzag path. See the example, honeybee flying. It is a zigzag motion. Now we will learn about distance. What is distance? The total length of a path taken by an object to reach one place from the other is called distance. Once again I repeat, the total length of a path taken by an object to reach one place from the other is called distance. Then what is displacement? The shortest distance from the initial to the final position of an object. Once again I repeat, the shortest distance from the initial to the final position of an object. See the example. The person moving from school to home is 7 meter. So here 7 meter as a distance. But shortest distance from school to home is 5 meter. That is displacement. So displacement is 5 meter. Then tell me, what is speed? Speed is simply how fast you are traveling. How fast you are traveling. See the picture. This car is traveling at a speed of 20 meter per second. Then what is velocity? Velocity is speed in a given direction. Speed in a given direction. See the picture. This car is traveling at a velocity of 20 meter per second in east. Let's see one example. A man drove a car from city A to another city B. He took route AOB and completed his journey in 10 hours. So distance travelled is equal to 400 plus 300 is equal to 700 kilometer. See the picture. AOB. Distance travelled is equal to 400 plus 300 is equal to 700 kilometer. Then displacement, that is shortest distance between city A and city B. Shortest distance is 500 kilometer. Next, speed. Speed is equal to distance divided by time. That is 700 kilometer divided by 10 hours. Speed is equal to 70 kilometer per hour. Next, velocity. Velocity is equal to displacement divided by time. Is equal to 500 kilometer divided by 10 hours. Is equal to 50 kilometer per hour in northeast direction. Now we will learn about acceleration. See the examples. Car and aeroplane going in a linear path, that is straight line manner. In which case do you think acceleration is involved? Let's see. Then where the acceleration involves? Object moves in a particular direction. In a certain point, the object changes the direction and moving. So the velocity changes. In a certain point, the object changes the direction and moving. So the velocity changes. So what is acceleration? Acceleration is defined as the rate of change of velocity. Acceleration is defined as the rate of change of velocity. So acceleration is equal to change in velocity divided by time. Acceleration is equal to change in velocity divided by time. See the picture. This is initial value, that is initial velocity. Then next point V is a final value, that is final velocity. So acceleration A is equal to V minus U divided by T. Final velocity minus initial velocity divided by time. Let's see the example. Objects move from A point and velocity is 0 meter per second. At B point, velocity is 10 meter per second. Also time taken A to B point is 5 seconds. So acceleration is equal to V minus U divided by T. That is final velocity minus initial velocity divided by time. So 10 meter per second minus 0 meter per second divided by 5 second. So the answer is 2 meter per second square. Acceleration is 2 meter per second square. Now we will study about atomic structure. All materials, whether they are solid like steel or liquid like tea or gaseous like air, are made up of atoms. Now tell me, what is atom? Atom is a small unit of matter. Atom is the smallest unit of matter. Atoms combine together to form molecules. Atoms are made of subatomic particles. They are protons, neutrons and electrons. Once again repeat. Atoms are made of subatomic particles, protons, neutrons and electrons. Students, protons and neutron in the center, also called nucleus. Electrons revolve around the nucleus. Electron moving path is called orbit. This is the structure of an atom. Do you know, children? Proton is discovered by Ernest Rutherford. Symbol is P. Charge is +1. Then proton mass is 1.6726 into 10 to the power of -27 kilogram. Then next, electron is discovered by Sir John Joseph Thomson. Symbol is small e. Charge is -1. Then mass of the electron is 9.1093 into 10 to the power of -31 kilogram. Next, neutron is discovered by James Chadwick. Symbol is small n. Charge is 0. Then mass of neutron is 1.6749 into 10 to the power of -27 kilogram. Students, the nucleus consists of protons and neutrons. Nucleus consists of protons and neutrons. Protons are positively charged. Neutrons have no charge. Negatively charged electrons revolve around the nucleus in circular orbits. Now we will learn about atomic number. The number of electrons or protons in an atom is called the atomic number of that atom. It is represented by the letter Z. Once again I repeat, the number of electrons or protons in an atom is called the atomic number of that atom. It is represented by the letter Z. So, atomic number of an oxygen is 8. That is, number of electrons in oxygen is 8. Next, we will learn about mass number. Mass number is equal to the sum of the number of protons and neutrons in the nucleus. It is denoted in capital A. Once again I repeat, mass number is equal to the sum of the number of protons and neutrons in the nucleus, otherwise called atomic mass. Atomic mass or mass number is equal to number of protons plus number of neutrons. So A is equal to P plus N. Students, what is symbol of an element? An element symbol is a 1 or 2 letter abbreviation for a chemical element name. An element symbol is a 1 or 2 letter abbreviation for a chemical element name. This is periodic table. 180 known elements present in periodic table. And from that we will learn about element symbols. See the picture, students. Always elements are represented like this. Here X is an element denoted in a single letter or 2 letters. Below the number denotes atomic number and the above number denotes mass number. See the example. Helium atom, that is capital H small e, is an element symbol. He is an element symbol. 2 is an atomic number. 4 is a mass number. Let's see some more examples. Capital C, that is carbon atom, is an element symbol. C is an element symbol for carbon. 6 is a atomic number. 12 is a mass number of carbon. Then capital N is a element symbol of nitrogen. Then 7 is a atomic number of nitrogen. 14 is a mass number of nitrogen. Then Cl is a symbol of chlorine. 17 is the atomic number of chlorine. 35 is the mass number of chlorine. Then capital C small o, that is cobalt. 27 is the atomic number. 59 is the mass number. So symbol denoted in one letter or two letter. In symbol of an element, below number is atomic number, above number is mass number. Now we will learn about valency. What is valency? The combining capacity of the atoms to form molecules either with same or different elements is defined as valency. Once again I repeat, the combining capacity of the atoms to form molecules either with the same or different elements is defined as valency. Examples: sodium has one electron in its outermost shell, so the valency of sodium is 1. Let's see the example. See the picture, students. 2 sodium atoms combines with 2 chlorine atoms to form sodium chloride. Here sodium shares one electron with the chlorine atom. So the valency of sodium is 1. Like that, valency of chlorine is 1. Let's see some more examples for valency. In hydrochloric acid, valency of your chlorine is 1. In water, oxygen valency is 2 because oxygen is able to bind it with 2 hydrogen to form water. So the valency of oxygen is 2. In ammonia, nitrogen valency is 3 because nitrogen bonded with hydrogen. 3 hydrogens. Nitrogen bonded with the 3 hydrogens. So the valency of nitrogen is 3. Next, CH4, that is methane. In methane, carbon valency is 4 because carbon combines with the 4 hydrogen atoms. So the valency of carbon is 4. Now we will study about electricity. Do you know, children? Thomas Alva Edison was an American inventor. In 1982 in New York, Thomas Alva Edison pushed the switches on and 14,000 bulbs in 9,000 houses suddenly got lighted. Once again I repeat, Thomas Alva Edison was an American inventor. In 1982 in New York, Thomas Alva Edison pushed the switches on and 14,000 bulbs in 9,000 houses suddenly got lighted. In 1899, electricity first came to India. In 1899, electricity first came to India. So, electricity is one of the need in our daily life. Electricity is one of the basic need in our daily life. Tell me, what is electricity? Electricity is a form of energy that is associated with electric charges that exist inside the atom. Once again I repeat, electricity is a form of energy that is associated with electric charges that exists inside the atom? Yes, proton carries positive charge, electron carries negative charge, neutron carries neutral charge. Then, what are the sources of electricity? Power plants are the sources of electricity. What are they? Thermal power plant, hydroelectric power plant, tidal power plant, wind power, solar power and nuclear power plant. So, power plants are constructed depending upon the natural resources available at that particular place. Now, we will learn about cell. What is cell? A device that converts chemical energy into electrical energy is called a cell. Once again I repeat, a device that converts chemical energy into electrical energy is called a cell. Depending on the continuity of flow of electric current, cells are classified into two types. First one primary cells, second one secondary cells. We will see one by one. Primary cells cannot be recharged, so they can be used only once. Hence, the primary cells are usually produced in small sizes. Once again I repeat, primary cells cannot be recharged, so they can be used only once. Hence, the primary cells are usually produced in small sizes. Let's see the examples for primary cells. In torchlights, alarms, toys, watches are used in primary cells. Next, secondary cells. A cell that can be recharged many times is called secondary cells. A cell that can be recharged many times is called secondary cell. These cells can be recharged by passing electric current, so they can be used again and again. While the secondary cells used in mobiles are in the size of a hand, the cells used in automobiles like cars and buses are large and very heavy. Let's see the examples for secondary cells. Secondary cells are used in mobile phones, laptop, emergency lamp and vehicles. Now we will learn about electric circuits. What is electric circuit? The path through which electrons flow from one terminal to another terminal of the source is called electric circuit. Once again I repeat, the path through which electrons flow from one terminal to another terminal of the source is called electric circuit. So, what are the parts in electric circuit? The electric circuit contains switch, bulb, wire and battery. Now we will learn about types of electrical circuits. Electrical circuits classified into two types, series circuit and parallel circuit. We will see one by one. First one, series circuit. If two or more bulbs are connected in series in a circuit, then that type of circuit is called series circuit. If any one of the bulbs is damaged or disconnected, the entire circuit will not work. Example, Christmas lights. Here, we'll see the bridges connected one after another. We will cross easily. But if the bridge collapses, we are not able to cross the bridge. If the bridge collapses, we are not able to cross the bridge. This is the disadvantage of series circuit and not preferred in our homes. Now, we will study about parallel circuits. If two or more bulbs are connected in parallel in a circuit, then that type of circuit is called parallel circuit. If any one of the bulb is damaged or disconnected, the other part of the circuit will work. So parallel circuits are used in homes. Once again I repeat, if two or more bulbs are connected in parallel in a circuit, then that type of circuit is called parallel circuit. If any one of the bulb is damaged or disconnected, the other part of the circuit will work. So parallel circuits are used in homes. Okay students, I hope you are clear with today's session. Study well. Thank you.